When I've told you multiple times, and I'll continue to tell you multiple times, I was a weird kid. And one of my favorite things to do was, like, in the wintertime, I'd just stick the poker in the wood stove and get it red hot, and then I'd try and burn stuff with it. Like, the carpet was one of my favorites, and that was also definitely not my mom's favorite, to have, like, little burned poker marks on the floor. Yes, I am my mom's favorite. There's no doubt about that. No, I can't imagine. If you're watching this, Mom, sorry. But I can't imagine that I am. I was her, what'd she call me? I was her 26-hour Christmas present, because she was in labor for 26 hours. And they had to break her tailbone to fit me out, so I wrecked her Christmas. And every day on my birthday, do you know what I was doing 38 years ago on this day? Yes, Mom, because you do this every year. I was in labor for you for 26 hours. They had to break my tail. Yes, I know, Mom. Thank you. And then, click, she just hangs up. Thanks, Mom. Love you too. Bye. Thanks for calling. So anyway, we've got, I forget how we got off track there, but this is what happens. Oh, yeah. Anyway, we've got this layer on the inside here, right, that is liquid, and it's liquid for a reason. It gets really hot, right? It is. But think about how hot it takes to get metal to a liquid stage. Even when you weld, you're using metals, and I don't know how hot those things get. How hot do those things get to liquefy? Is that true? 53,000? Okay, so this, it's not quite in that temperature range, because you guys are melting different metals. This is in like the 5,000 to 6,000 range. But that's way hotter than like that red burner on your stove. So if you were to, put your hand on the red burner on your stove, it would be cooler than this is. This is hotter than your oven can get. This is hotter than the stuff that we commonly have on Earth, is this thing. And then inside of that, obviously, we've got the very center of our Earth is called the inner core. I just can't find one that wants to work. So we've got the inner core. Inner core, solid, liquid, or gas? It is solid. And then it's made of the same stuff. So it's solid for a reason, though, because it's hotter, which would make you think it should be a liquid. So this thing is cooler than this, temperature-wise, but which should make this a liquid, but something keeps that a solid. What could prevent that from melting? I thought I heard it from... Yeah, pressure, whoever said that. Who was me? Oh, all right. So the Earth is pushing in on that so much that when it tries to melt, when stuff melts, everything except for water, when it melts, it has to take up more room. And this can't take up any more room because it's getting pushed on so hard. So it stays a solid. It's like a red hot, hotter than this liquid stuff, solid ball of iron and nickel that's in there. So it is iron. Iron and nickel is what it's made up of. And then something's got to keep it hot. And the thing that keeps it hot is this. It's called radioactive decay. That's the same thing they used to use in nuclear power plants and stuff like that. They use radioactive materials to run nuclear power plants, to heat water, to turn it to steam, to do its thing. That's what keeps the inside of our Earth warm, is radioactive decay. And you can even feel that as you start to, even though we've never been through the crust, as you start to go down in mines that go through the crust, I think we get down like 2 miles or so in mines, it gets hotter, like into the 120s, just a mile or two under the Earth. So you still have all that way to travel to get through there. And it's like, I want to say it's about 4,500 miles to get down there. So it'd be, this distance from the center here to the edge is farther than it would be driving from Oregon all the way out to like somewhere on the East Coast, like Massachusetts or something like that. That's how, like, as you stand like this, if you went from here to the East Coast, like straight down like that, that's what's down here.
How long do you think it would take?
Well, it depends on how fast you went.
It took me 10 days.
There you go. Oh, going to the East Coast? Is that what you were asking? Yeah. I did it in 3 days, but it wasn't very pleasant. But, I mean, you're talking, so, I mean, no matter where you're at on Earth, straight below your feet, 3,000 miles, is like a multiple 1,000-degree ball of hot metal that's just hanging out there, waiting to get discovered.